Hi friends, I'm really excited to do today's question, and it is it requires basic concepts while uh, many can flip on small silly mistakes right here. But it is an interesting one. We have been given the alpha, the RA and the EC. Let's get ahead. At autumnal equinox, so we have condition for rising is x equals 0. So sin h, a star rises when its altitude is 0, right, as equals 0 degree. So sin h is going to be sin phi for h equals 0. Cos of h is going to be, put the value of and then declination, you will get our angle as I calculated it already. So at rising, the star must be east of meridian, and west of meridian, considering it is positive, east will be negative. So just write negative right here. 5 hour 50 minute. Find the LST when we have LST equals our angle plus RA. So RA we have been given as this. When you add it, you will get 5 hour 45 minute and 53 seconds. So Sagarmatha rises whenever the local sidereal time in Kathmandu reaches 5 hour 45 minute 53 second. So at autumnal equinox we have RA will be 12 hour. Using the given equinox time 6:28 p.m. Kathmandu's level sidereal time is going to be approximately this plus 6:28, which is 18 hour 28 minute. This is the approximate time. Yeah. At that instant, it is going to be that. Um, so consider one thing. Okay, I didn't give you the time to see the question right here. You could see the question right here. Wait. Yeah, you have read the question. Yeah, 1822 we are here. So from September 2022 to October 26, we have 14 days. We know 1 degree equals 4 minutes, which is actually it is 3 minutes 56 seconds. So just add for 14 days, 14 multiplied with this, you will get 54 minutes 50 seconds, I guess. Yeah, I suppose this is the answer. You could do this. And LST at 6:28 p.m. on October 6 will be equal to 18 hour 28 minute plus 54 minute 50 seconds something. We will get 19 hour 23 minute something like that. Okay, so we need to find the LST when we need to find when LST reaches 5 hour 45 minute 53 second, because this is the time when it will rise. So at 6:28 p.m. the LST is this, but we need the LST this. Then 24 minus 5, I mean minus 19 hour 20 minute plus 5 hour 45 minute, it is going to be 10 hour 16 minutes, something like that. So star rises about 10 hour 16 minute after 6:28 p.m. Then add 10 hour 16 minute plus 18:28, you will maybe get 4 hour something near 4 hour 48 a.m. I guess this is the answer for it. So Sagarmatha rises approximately at that. Another question we do have is, mm, yeah, the angular resolution, and we know always the spherical distance formula. The spherical distance formula is, as always it is, cos theta equals sine delta 1 sine delta 2 plus cos delta 1 cos delta 2 and cos alpha 1 minus alpha 2. And it is going to be, this is a universal formula, whether it is the difference in longitude, right? It is this AB. Suppose this is A star B star A star B. These are the things. Just this works for any sphere. Just any sphere. So just plug in the formula right here. We have alpha 1 as, I guess, mm, you can, we have the difference. The alpha 1, the RA of Sagarmatha is 11 hour 35 minute, and of Leo is 11 hour 16 minute. Get it done and write the delta alpha in degrees, which comes approximately as 4.8083 degrees. As we know, 1 hour equals 15 degrees. You can convert 19 minutes 14 seconds into hour and then multiply by 15, right? And we know the delta of both the stars. So then you will get, as a function of inverse of cos theta, you will get theta you must get it around 4.92 degrees. So that's it. We had a couple of formulas like cos s equals minus tan phi tan delta, LST equals sum of our angle and right ascension. Those were the formula needed, and little calculation tricks we need here in calculation of this. It was an interesting question yet short. Thank you.